Hello, my name is Gene Kim, and I've been studying high-performing technology organizations for 25 years, and I'm so delighted to be presenting today at LaunchDarkly's Technology Migration Summit. This is such an important topic because I think one of the worst things that we can do as technology leaders is make changes dangerous and risky and drive up the cost of change. And it's reducing cost of change that has everything to do with architectures, of which feature toggles and management is such an important and relatively new addition to. My journey studying high-performing technology organizations started when I was a CTO and founder of a company called Tripwire back in 1999. This was an information security and compliance company. Our goal was to study these amazing organizations that simultaneously had the best project due date performance and development, the best operational reliability and stability in ops, as well as the best posture of security and compliance. We want to understand how did these amazing organizations make their good to great transformation so that we could understand how other organizations could replicate those amazing outcomes. And so as you can imagine, in a 25-year journey, there were many surprises, but by far the biggest surprise was how it took me into the middle of the Devops movement, which I think is so urgent and important. The last time that any industry has been disrupted to the extent that all our industries are being disrupted today was likely in the 1980s, when the U.S. automotive market was upended by the entrance of Toyota into the U.S. market. And I think that's exactly what DevOps is. You take those same lean principles, apply them to the technology value stream that we work in every day, and you end up with these emergent patterns that allow organizations to do tens, hundreds, or even hundreds of thousands of deployments per day without sacrificing world-class reliability, security, and stability. And interestingly, deeply embedded in the Toyota production process is a notion of dramatically lowering the cost of experimentation and the cost of change. So here's what I'm going to be talking about today. I'll be talking about the metrics of high-performing technology organizations based on the state of DevOps research that I did with Dr. Nicole Forsgren and Jez Humble from 2013 to 2019, why architecture and modularity are so important because they create independence of action. And then I'm going to talk about my favorite examples from large, complex organizations, organizations that have been around for decades or even centuries, who are using the same technical practices, architectural practices, and cultural norms that were invented by the tech giants and using it to help their organizations win in the marketplace. So the first thing I'll talk about is the state of DevOps research. And so what we found in this cross-population study that spanned over 36,000 respondents over 6 years was that high performance exists and they massively outperform their non-high-performing peers. As measured by what? One of them was deployment frequency. We found that these high performers deployed multiple times per day. So that's 2 orders of magnitude more frequently than their peers, and they deployed more quickly. They were able to go from code committed into version control, through integration, through testing, through deployment, or making the feature available so that customers are saying thank you. They could do that in 1 hour or less. Again, 2 orders of magnitude more quickly than their peers. But more importantly, they were able to get far better outcomes. When they did a deployment or a feature release, they were 7 times more likely to have it succeed without causing a 7-1 outage, a service impairment, a security breach, or compliance failure. And when something went wrong, which Murphy's Law almost guarantees, they could fix it in 1 hour or less. And that's 3 orders of magnitude faster than their peers. And so the point here is that we can make changes more quickly and more safely. And this is what we found for 6 years in a row, is that the only way that you can get these reliability profiles is to do smaller deployments, smaller releases of functionality more frequently. Over the years, we expanded our lens and looked at other dimensions of quality. We found that high performers, because they are integrating information security objectives into everyone's daily work, they're spending only 1/2 the amount of time remediating security issues. We also started looking at organizational performance. What we found is in these high performers, not only did they have these great technology measures, but they were also twice as likely to exceed profitability, market share, and productivity goals. And for not-for-profits, for example, government agencies, military services, we found that the same multiple of performance. They were twice as likely to achieve organizational and mission goals, regardless of how they measured it, whether it was customer satisfaction, quantity, or quality. We looked at other markers of organizational performance. We found that because these high performers, employees were twice as likely to recommend their organizations as a great place to work to their colleagues and friends, as measured by the Employee Net Promoter Score. And so in an age where retention and the ability to recruit is so important, this has never been more important. And so to me, beyond the numbers, what this suggests is that these are the practices that allow us to safely and quickly, reliably, and securely achieve all the goals, dreams, and aspirations of the organizations that we serve. So one of the biggest surprises to me in the state of DevOps research is to what extent architecture matters. It is one of the top predictors of performance. As measured by what? To what extent can teams make large-scale changes to their parts of the system without permission from anyone else outside of their team? To what extent can they complete their work without a lot of fine-grained communication and coordination with people outside of their team? To what extent can they deploy or release their service on demand or their feature independent of other services it may depend upon? I love this one. To what extent can they do their own testing on demand without the use of an integrated tester environment, which there are never enough of, they're never cleaned up, and actually couples us to everyone else who uses those integrated tester environments, often the rest of the enterprise. And if all those things are true, we should be able to do normal deployments during normal business hours with negligible downtime. And so what we found is that this is what shapes the type of work we do in our daily work as developers, anyone in the technology value stream. And so I will be motivating why I think this is so important. And I just want to take a moment to distinguish continuous integration and deployment from feature flags. So in the state of DevOps research, we said there are 3 determinants of success: technical practices, architectural practices, and cultural norms. Technical practices include things like automated testing, continuous integration, and continuous deployment. Architectural practices are the way we organize our code and our organization, and feature flagging actually fits here. And then we have cultural norms. So let me explain why architecture is so important. So this is actually the emerging basis of a book that I've been working on with my friend, Dr. Stephen Spear at the MIT Sloan School of Business. And so we've been working on this for 3 years. I've been working with him for a decade. And the name is Wiring the Winning Organization: Unleashing Our Collective Greatness Through Slowification, Simplification, and Amplification. And it has everything to do with how we connect teams and their code to other parts. And so just to create a very simple metaphor of why this is so important, consider 2 people moving a couch. Let's call them Steve and Gene. Yeah, so you might think this is all brawn work, but it actually requires a lot of brain work. And there's actually a ton of communication coordination that's required. Because when they start, they are immediately in conversation and they have to answer questions like, where's the center of gravity? If we could go through this narrow doorway, around which axis do we rotate? To go down a narrow set of winding stairs, who goes first and should they go forwards or backwards? And what's remarkable is that the instant they pick up the couch, they are immediately in conversation, doing trial and error, and using feedback to come up with answers to those questions. They don't need focus groups. They don't need consultants. This is something that Steve and Gene should be able to figure out for themselves. And as leaders, there are many things we can do to make their work very difficult. For example, we can turn off all the lights, so they can't see what's around them. We can actually add a lot of background noise, like a siren or loud music. And so this, unlike turning off the lights, doesn't actually change the inherent difficulty of the work, but suddenly Steve and Gene can't communicate, coordinate, exchange information with each other. And the same thing happens if we put in an intermediary that prevents Steve and Gene from talking directly with each other. Instead, they have to go through ticketing, through Jira forms, etc., right, which reduce the bandwidth of information that can flow from Steve and Gene and vice versa. And this is the concept of coherence. To what degree can the components in the system act as a unified whole, which requires logical and consistent behavior? The other thing to remark here is that there's also coupling. So Steve and Gene moving a couch, they are inherently coupled. What affects Gene affects Steve and vice versa. Versus Gene and Steve moving 2 chairs together, which can be done independently with very little need to communicate and coordinate. And so software architects would say, oh, I recognize this. What this means is, to what degree can we do what we need to do merely by changing one side of the interface without having to change the other? So the instant you couple them together, they need to communicate, coordinate, potentially schedule together, prioritize together, deconflict together, maybe even deploy together. And so there's tremendous value in allowing independence of action. And I think one of the best examples that we will recognize in our field is what happened to Amazon around 2004. So back in 1998, It was Amazon was a pretty simple tech stack. It was actually run in Netscape Server. It was written in C++, those Abidos plugins. You had two databases, Berkeley database for the book listings and the Oracle database for e-commerce transactions. And you can imagine you had teams emerging on the e-commerce side, product page, shopping cart, ordering, returns, inventory. And then you had this other orthogonal axis of product listing for books. But then you add music. By 2002, you actually have 32 different categories. And so what this means is that you have 32 different product teams, potentially 6 or more e-commerce teams, all of them who are connected to each other, coupled together. And so when anyone has to do something, they have to communicate and coordinate with potentially all the other teams. And this came to a head in 2004. Dr. Werner Vogels, in this famous ACMQ article, described how in 2005, certain teams wanted to add something to the order pipeline. Like this was the digital teams. This was Amazon Music, Amazon Video. And the ordering pipeline required that a physical delivery address be provided. There was no way around it. And so the digital teams had to go to 80 different ordering teams and say, we need to change this. To which the ordering teams would respond, they hadn't budgeted for it. And so now all those teams were stuck. And so it actually gets worse than this. In 2002, Amazon had to ship clothing and apparel. And so clothing, this was the first introduction of clothing SKUs, shopkeeping units. So these are things that you find in many retailers that encode category, like sizes, styles, color, gender, and so forth. And so because of this, the apparels team not only had to communicate and coordinate with all those e-commerce teams, but they had to make global changes, database schema changes. And so as Jesse Robbins, famous for his Amazon Game Days exercises that are so well chronicled in the Devops handbook, he said changing product SKUs required database schema changes, which were very disruptive. They caused most of the global outages at Amazon, sometimes even corrupting the database, sometimes causing multi-hour outages. So we never had any SKU variants before, let alone 50. And so you can think about the Amazon code base that started to look like this, where everything became very complected. They became entangled, tightly intertwined, where any small change could have caused global problems. And so this is bad, but is not as bad as what it became, which looked like this. So Amazon's conundrum was that it reduced the independence of action. In the early days of Amazon, Jeff Bezos described how he wanted doers. That meant engineers, developers, merchandise buyers, but not managers, right? Not coordinators of work. And so the sweeping edict that came out in 2002 was his desire to create and reorganize the company around 2 pizza teams. In other words, teams no larger than could be fed by 2 pizzas, who could be unleashed to work independently to solve Amazon's biggest problems. And the goal is to communicate less and not more. And so Steve Yegge, formerly at Amazon, then at Google, he described this audacious 7-point memo that Bezos published, which triggered this $1 billion Amazon API re-architecture. The main points here are all teams must henceforth expose their data and functionality through service interfaces, or APIs. Teams must communicate with each other only through these interfaces. No other form of inter-process communication is allowed. Anyone who doesn't do this will be fired. Thank you and have a nice day. Steve Yegge jokes number 7 is obviously not true because Bezos doesn't care whether you have a good day or not. And all of this was enforced by then Amazon CIO Rick Dalzell, former Army U.S. Ranger. And so the outcome of this is that they created hard modular boundaries between teams so that that wiring diagram started to look like this. Where now teams have independence of action. Changes could be made where impacts were isolated without causing global disruption and chaos. And so architecture is often so elusive. This diagram looks pretty good, but it's because you don't see what's at the bottom, right? Arguably, this is probably as bad as the terrible wiring diagrams that I had showed you before. So what was the outcome of this? So the before state was in 1999, they could do probably thousands of deployments per year. By 2001, they're doing tens of deployments per year. But by creating these hard modular boundaries, by creating modularity inside of Amazon, they were able to go to 2011, 15,000 deployments per day. By 2015, they're doing 136,000 deployments per day. So by creating these hard modular boundaries that create independence of action, there's no doubt in my mind that this set the bar in terms of what the frontiers of performance looked like for the entire technology community. And so recall what that looked like. Architecture, we said from the State of DevOps research, it was to what degree can teams do their work independently without a lot of fine-grained communication and coordination with people outside of their team. So the words I've learned working on the Wiring the Winning Organization book is independence of action. I also learned that there are two types of problems that Amazon solved for. One was avoiding design time coupling so that changes can be made just on one side of an interface. And then runtime coupling, right? We want changes when bad things happen, we want them to be contained into that module, right? As opposed to rippling out and causing global chaos and disruption. So let me share with you my favorite examples of architectural transformations that isn't at a Facebook, Amazon, Netflix, Google, or Microsoft. And so this is based on the work that I've been doing since 2014. I've been hosting a conference called the Devops Enterprise Summit for organizations that have been around for decades or centuries across almost every industry vertical. The oldest organization I presented was UK HMRC, His Majesty's Revenue and Customs Service, which was founded in the year 1200. So across these over 1,500 talks now, we've had talks from almost every industry vertical, showing how they are using these practices to win in the marketplace. So one of my favorite case studies that I've ever been able to study was Target. So in the US, they're the 5th largest retailer. And in 2014, Heather Mickman and Ross Clanton, two then directors of engineering, talked about how they were transforming how engineering was done at Target. This was back when engineering was almost 80% outsourced, and now they are nearly 100% insourced. And so the business problem that Heather set out to solve was this. Every time that a developer wanted to get access to a system of record, so that's product, pricing, promotions, orders, returns, store information, they would have to wait 9 months because every system was integrated point to point. They would have to wait for the integration teams to set up the integration. And so this was the biggest bottleneck inside of Target. So what did she do? They created something called the API Enablement Project. So they essentially copied and started synchronizing data from hundreds of systems of record into a Cassandra database, created versioned APIs so that any team could, on demand, once they got approval from security, of course, could add, retrieve, and even delete information on demand, right? So it didn't have to wait 9 months, they could do it immediately. And so by the time she presented in 2016, she talked about how this enabled hundreds of services and applications to be developed running on this capability because it decoupled the development teams from the systems of record. And at this point, I think she had like 180 engineers making this possible. This enabled the Starbucks integration, the in-store apps that the employees used, the ship-to-store capability, which is very important if you're trying to compete against Amazon, and just showing how strategically important this program was. In 2019, Scott Havens, then Director of Engineering at Walmart, his remit was to rewrite the inventory management systems from Walmart, the world's largest retailer. And one of the most amazing things that he talked about was the before state, which is that if you go to walmart.com and look for item availability, it required 22 deeply nested API calls, which meant that all 22 services had to respond within 50 milliseconds as part of the SLA, and they had to run at 4 nines, which is incredibly expensive because if any one of them went down, no one could actually order items. And so he talked about this incredible audacious re-architecting of the system, more towards event sourcing, reducing that item availability information lookup from 22 API calls down to 2, which were actually lookups in a key value store, which relaxed the SLA requirements. So they didn't have to run at 4 nines, they could run at 2 nines. They didn't have to respond in 50 milliseconds, they could respond in seconds. And so dramatically increasing the availability and dramatically lowering the cost of running these services in production. All right, last example, Honeycomb. It was a phenomenal talk at AWS reInvent about such a novel use of feature toggling. So most feature toggling we think of, is a feature available or not available, and what percentage of users do we want to expose it to? they presented such a novel case of something on the back end that a customer should probably almost never see. And so their business goal was to migrate Kafka from the x86-64 architecture to Graviton 2, right? Because the cost of these instances are much lower. And she describes how in one instance, due to some either misconfiguration or JVM error, they actually increased the cost of running Kafka by 50x, which actually is more than material change in running the back end of Honeycomb. And so they started using feature toggles to shape and route traffic through these new Kafka interfaces, so they could manage the risk of migrating from the x86 to ARM. So I think this just shows how powerful of a capability it is when we can reshape the way information flows, how traffic flows, without requiring communication coordination. There's a wonderful quote from Winston Churchill. He said, "We shape our buildings, and thereafter they shape us." And so too, as technology leaders, we shape our architecture, and thereafter the architecture shapes us. So if you're interested in learning more about wiring the winning organization, just send an email to realgenekim@sendyourslides.com, subject line DevOps, and you will get an automated response in a minute or two. Thank you so much, and I'm so much looking forward to learning with you from John Kojumal and his fireside chat with Kate Halterhoff from RedMonk. Thank you.